just want to finish up our lessons from the previous days by doing some mixed review problems. And the first problem I'm actually going to turn my attention to is number 2. So regarding higher powers of I, if we remember our rules of I, every time we get I to the 4th or any multiple after that, I to the 8th, I to the 12th, I to the 16th, we get back to the number 1. So even though 4 doesn't go into 27, I can still take 4 into 27 and just mention what my remainder was. So 4 goes into 27 6 times. So this is the same thing as saying if I take 24 I's, I would need 3 more. 6 times 4 plus 3 would get me back to 27. So I to the 27th could be written as I to the 24th times I to the 3rd. And the 24th would be I to the 4th times to the 6th power. However you want to break that up is up to you. I just try to expose these groups of 4 because I know that that's the same thing as 1. And if you forget what I cubed is, you can always make it I squared and I to the 1st, and then you could simplify from there. Since this is -1, 1 times -1 times I is just going to be -I. So I to the 27th would get me back to -I. So we'll try that again with number 3. So let's say off the top of your head, you're not sure if 4 goes into 58. So I don't know if this is going to be an extension of I to the 4th or not. You can break 58 into any kind of problem you want. Something that I think is really easy to do is just take 40 plus 18, and we know that's 58. I chose 40 because 40 is a multiple of 4. And then I'm going to take 18 and I'm going to break that into 16 and 2 because that way 16 is a multiple of 4. So I'm trying to get these exponents to be multiples of 4, and now just pay attention to what I have left over. And the reason I'm trying to get them to be multiples of 4 is I can manipulate this then to be I to the 4th to the 10th power, I to the 4th to the 4th power. So I can rewrite 40 as 4 times 10 and 16 as 4 times 4. By doing that, I can now make this number 1. I can see that that's 1. I can see this is going to be 1. So really what I'm going to have is -1 as an answer. I to the 401st power may look nasty, but it's actually very simple. 400 is definitely a multiple of 4. So I'm trying to get these exponents to be multiples of 4 again, and I'll have a remainder of 1. 400 plus 1 is 401. Since this is a multiple of 4, this is going to just become 1. It's I to the 4th 100 times. Well, that's the same thing as just 1. And I to the 1st, of course, is I, so this answer is just I. Now that we did a couple of these larger powers of I want to jump back to just a sample problem where we have these 2 variables and what appears to be one equal sign. So let's go ahead and set the real component equal to the other real component and the imaginary component equal to the other imaginary component, and then we'll go ahead and we're going to solve for x. There's lots of ways to do this, but I would probably just multiply both sides by 1/6 to get x alone. Then that's going to get me 1/14 when I'm done. If I want to isolate y, I'm just going to divide off the I from each side, leaving me with 4/5 y and -13, and then I would just multiply both sides by 5/4. That gets these guys to become a 1, and this side to become, it should say -65/4. Sorry about that. -65/4. Then we turn our attention to the bottom row, and I do see an issue here. I actually see 2 issues. 6 and 9 can reduce, so I would want to reduce those, but also I have I in the denominator. That's the same thing as having root -1 in the denominator, and we're not supposed to leave radicals in the bottom. So however we want to handle this first, we just need to make sure we address all the issues. We're going to multiply by I over I, and get 6i over 9i squared. Since I squared is -1, my denominator becomes -9, and then I can reduce these both by 3 and get 2i over -3, You could also have negative 2/3 I. You could have negative 2i over positive 3. As long as you have a negative somewhere, it doesn't matter. However, we learned we can't use that trick for a problem like 6 or 7 because of this minus sign down here. So if we put an I right here, we'd have to distribute it, and I would end up having one I as part of my denominator, which I'm still in that jam then of having I in the bottom. So we want to use the conjugate, 3i plus 1, top and bottom, and then we're going to do some distributing up top. Then we're going to do some foiling on the bottom. I know that I squared is negative 1, so if I multiply that by 9 and subtract 1, I get negative 10. And then we do want to reduce 36/10 and 12/10. So I can make this problem now 18i plus 5, or excuse me, 18i plus 6 over negative 5. And it'll be the same thing for number 7. I want to use the conjugate I plus 4 so that I can truly get that I out from the bottom. The only difference is I'm going to have to FOIL. I have two things up here that I need to multiply by I plus 4. So we have to distribute the 2, and then we have to distribute the 3i. When I do that, I'm going to get the following numerator, and then in the denominator, I'm going to get an I squared and a negative 16. We'll clean up the top a little bit here. I can put my 12 and 2 together to make 14. 3i squared would be negative 3. And on the bottom, negative 1 minus 16 is negative 17. And then we can just clean that up a little bit more. So we get 14i plus 5 all over negative 17.